I am meaning, yes. All right, we're still on the same objective, guys, and the same standard. Um, well, actually, the same standard. I'm going to revisit a concept that some of us are still having a little bit of a misconception. So here we go. It says, number quantity. I'm looking at us practicing more properties of exponents. Okay? So we already did some of this, and I introduced it a different way. So hopefully today we'll clarify some of those doubts. Okay? However, I also talked to you about attending to precision. Look at math practice standard number 6. Attend to precision. Remember that? On the party, I specifically told you for number 23 that you needed to write a statement and at the end write in feet. 8 by 8 feet. And some of you, once again, you just wrote 8. You got to be more attentive to precision, guys. Also, look at this one. Math practice standard number 7. Look for and make use of structure. What does that mean? We've seen numbers and squares and how those are organized and put together. Have we been using the area model? Yes, how we can translate some expressions into area models. That's what this is talking about. Okay? But anywho, let's get started. Our objective for today, I can write and evaluate powers. Read together. 1, 2, 3. I can write and evaluate powers. Our title for the lesson is Powers and Exponents. Write that at the top, please. The bottom left, write your objective. And our concept for today is powers. And like I said, I already introduced something similar, very similar, some time back. And the only thing, this is a little bit more of a simple introduction. And that's why today's homework probably is going to be one of the easiest ones you've ever done. Ever. This day is more of me clarifying a lot of little misconceptions, okay? Here we go. So, concepts. Powers, what are they? Expressions written with an exponent and a base. Expressions written with an exponent and a base. Expressions written with an exponent and a base. That's it? Yes. Let's look at it. Example, 4 to the second power. Is that an expression written with an exponent and a base? Yes. How about x to the third? Yes. Expression written with an exponent and a base. How about negative 5 to the fourth? Yes. Expression written with an exponent and a base. How about parentheses, negative 5 to the fourth? Yes. Expression written with an exponent and a base. Non-examples. They're over here. 2 times 6, 3/4, and x plus 3. So as you're writing these down, why are these examples, according to the definition? Why are these non-examples? Just think about it as you're writing those down. So, put together this lesson. Check this out. So, by looking at it, we see that these do not have exponents. Is that correct? Yes, these do. And these have, well, actually, they do have invisible exponents of what? 1. So, therefore, to be a power, it needs to have exponents greater than 1. So, what makes powers powers? They need to have bases and exponents, and specifically the exponents greater than 1. Okay? Copy that. And as you're copying that, I'm going to go ahead and explain a couple more things right here. Something that I want to clarify. Okay? So, check this out. I introduced, when we started the exponential expressions, I did the same thing. I said, this piece right here is known as the base. And this one right here is known as the exponent. And pretty much in this expression, the boss is the exponent. And the exponent tells the base how many times to multiply itself. So let's see, what is the base here? 4. How many times is it going to multiply itself? Twice. That's why this is 4 times 4. And what is 4 times 4? We simplify it, it becomes 16. Okay? So by looking at the next one, what is the base on the next one? X. And what is the exponent? 3. So what does that say? The boss tells the base to multiply itself how many times? 3 times. X times X times X. So far so good? Okay. Now, look at these two. Do they look similar? Yes, except one with parentheses, one without. And once again, Pens down, eyes up here. I'm going to explain it again. I already did this time back, but I'm going to do it again specifically in this lesson for this. Pay attention. I said, I can rewrite, and I said, check this out. I introduced it like this. All right, guys. Is it true if I write -2, will you agree that this is -1 times 2? Yes. Or if I write -3 is the same as -1 times 3? Yeah. So therefore, with that same idea, look at this one. This is -1 times 5. But here, how many times does it multiply itself? This is 5 times 5 times 5 times 5. Do you see? Now check this out. Now look at this one. What's inside of the parentheses? -5. And this says to multiply itself how many times? 4. This becomes -5 times -5 times -5 times -5. So check this out. Are these the same sign? Yeah, so the answer will be a positive for those two. How about this one? A positive, so positive times positive, so then the answer is a positive. 5 times 5 is 25. 25 times 25 is 625. That's it. However, 5 times 5 is 25. 25 times 25, we know it's 625. But what does it have at the beginning? -1. So this becomes -625. Do you see how now this is not the same as this? Okay, copy that, please. No, in the little box if it fits. All right. So with that said, we need some steps. Underneath that, you can fit these 3 steps. Here we go. Oh, and by the way, look at it. Didn't I introduce this like this? Exponential expressions, remember that? Very similar. Same thing, just a different name to it. Okay. Steps. To write any value powers, I identify the repeated factor, which is the base, and count the number of times it multiplies itself, which is the exponent. Once again, identify the repeated factor, which is the base, and count the number of times it multiplies itself, which is the exponent. In other words, for those of you that want it in simple words, step 1, identify the base and exponent. Is that a little bit simpler? When you see an expression or a power, identify which is the base and which is the exponent. Why is it so important to know the exponent? Because that tells you what? How many times the base multiplies itself. Okay? All right, here we go. So that was step 1. Step 2. Once you identify that, then compute. Compute the factors, which means multiply it out. Compute the factors, which is multiply it out. So now, look at step 3, or last step. Your last step is always to do what? Simplify. But when we got to exponential expressions, I remember when I asked you to simplify, I said, especially those that have small exponents and bases, you can actually simplify them completely. But some of you keep forgetting, so here I wrote it out. Simplify means write the value without exponents. That's what it means. Simplify means write the value without exponents. So 3 simple steps. Step 1, identify the base and the exponent. Step 2, compute the factors, which is multiply out. And step 3, simplify. And what does that mean? Write the value without exponents. So far so good? All right, example 1A and B. Turn over your papers. You can do this in the back. And if you want to do them one on top of the other and then leave space on the right-hand side so you can, example 2A and B are going to be very similar. Okay? All right, here we go. Example 1A and B. And by the way, here it goes again. Which is the base here? 3. And which is the exponent? 2. Okay, so now we got it. All right. Copy this. For those of us that are artistically challenged, let me help you out. Here it goes. It says, example 1, write the power represented by each geometric model. So this one is fairly simple. You draw a big square. And halfway here, and halfway there. Wait a minute, that looks like the area model. All right, this one. Here we go. Start with a square. And then I'm going to look at this corner, and this corner. And I'm going to draw diagonals to the right, the same distance, same size. Here's one. I'm going to draw another one exactly about the same distance, same size. And the same thing for this one. And now it looks like somebody turned over a table. Do you guys see it? Yeah. Okay, here we go. So from there you just connect this one to this one, and this one to this one, and then just add a little bit more right here inside. You can just write. What? What is it? You guys didn't get it? Jack in the box? No? Oh my goodness. Alright, here we go. So, now that you already have your sketches, so check this out. I'm going to go ahead and do this one. Pens down, please. Eyes up here. So, look what it says. It says, write the power. Are they saying to simplify it? No, they just want us to write a power. What does that mean? Write an exponential expression. So check this out. This is a square, and I know, let's say this is unit of 1. This is another 1. So therefore, this side should measure 2. So if this is a square, what does this side measure? 1, and this one 1. So what is this entire side? 2. So to find the area, we know that we multiply side by side. So this is 2 times 2. And how can we represent this in a power form? 2 to the square or to the second. And with that same idea, look at this one. This times this becomes x times x times x. And what is the power for that one? X to the third or cube. Copy that, please. All right, here we go. So copy these next ones and see if you can do this next one by yourself. Here we go. And you can copy it right next to this. Here we go. Example 2A. All right, so everybody copy this and you did this by yourself, right? So it says, example 2B, was it? Yeah, 2B. It says, write the power represented by the geometric model. So this, you should have written the power, which is 1 to the second exponent. Is that correct? All right, copy this next one down, please. Copy this one. Example 2C. Very similar to the other one that we did. See if you can get your power for that one. Everybody done? Okay, how about now? All right. Did they say to simplify? No, that means we don't multiply it out. We just need the power. Let's see. So this became 5 cubed. Is that correct? All right. So far so good. That's what it means to write the power. So now let's find out what it means to simplify. And just a caution. I already explained this, right? That -2 in a parenthesis is not the same as -2 without a parenthesis. Is that correct? All right. So let's move on. Copy these, please. And label these example 3. Example 3. I know it's one behind. Example 3. Look at the instructions for this one. What does it say? Simplify. So for this one, we're going to do all 3 steps. Number 1, identify the base and the exponent. Number 2, compute. And number 3, simplify, which is writing it without any exponents. Okay? All right, here we go. So let's do this one. What's inside of the parentheses? Negative 6. So we write it negative 6 times negative 6 times negative 6. Okay? So from there, look at these two signs. Are they the same sign? So the answer is a positive. Now look at this one and this one. Are they the same sign? No. So that means our answer will be a negative. Are we done with the sign? Okay, now let's focus on computation. What is 6 times 6? 36 times 6. Let's see, 36. That's 6. I got 3. 6 times 3 is 18 plus 3. That's 21. So that's negative 216. If you don't see it, then stack them and multiply them. Okay. Let's do this one. Everybody look up. Look at this one. Is this in a parenthesis? No. That means I need to write first the what? The negative 1. The negative 1 times, what does this say? What is the base? 10, and the exponent 2. So this is written as 10 times 10. Is everybody following? So therefore, what is 10 times 10? 100 times negative 1, that's negative 100. Yes. Okay, here it goes again. I just explained that negative 2 is the same as negative 1 times 2. Negative 3 is the same as negative 1 times 3. So how about negative 10? What is that? Negative 1 times 10. Is that correct? However, if they give us negative 10 squared, that means negative 1 times 10 times 10. Why 2 times the 10? Because the exponent tells us that this one, how many times? Twice. Everybody see that? All right. So, let's move on. Copy this next one, please. Example 2C, or what are we on? 3? 3C? Okay, 3C. Copy that. Parentheses, 2 9s squared. Same process. Let's rewrite it first. What's inside of the parentheses? 2 9s. How many times is multiplying itself? Twice. So this is 2 9s times 2 9s. So let's see. What is 2 times 2? 4. What is 9 times 9? 81. Can we simplify to lowest terms? Nope. We're done. Right. Okay. So far so good? Okay, let's do a couple more. Here we go. Example 4. Example 4. For A and B. So this is parentheses negative 5 to the third power, and this is negative 6 squared. See what you get. Go. All right, here we go. So for this one, you should have written negative 5 times negative 5 times negative 5. So this became negative times a negative is a positive times a negative. This is a negative 125. Hands if you got that. Okay. This one needs to be rewritten. Doesn't have a parenthesis, so it's negative 1 times 6 times 6. So this became negative 36. Hands if you got that. That is correct. So now you understand the difference from one to the other. This is a common mistake that I saw you guys make with the exponential expressions. All right, so with that said, check out this last one. All right, pens down, eyes up here. So when you get to these word problems, check this out. First thing you've got to identify is the increments. By how many is it incrementing? So in the case of a school closing, the PTA president calls 3 families. Each of those families calls 3 other families. So what are the increments? What are the increments? 3. So therefore that would be our base. So therefore they're saying after the 4th round, guess what? That would be our exponent. So let's see how many families got called. 3 times 3 times 3 times 3. This is 9 times 9, which is 81. Everybody see that? Let's see if you can do that on this one. Everybody look up. You don't have to copy this, just pay attention. It says, a playground slide that does not get clean grows bacteria at a rate of two, pay attention, 2 every hour. So let me show you. So after 1 hour, how much bacteria? 2. After the second hour, another 2. So what is the one that repeats? So that is our base, okay? And it says, how many bacteria will be on the slide after 8 hours? What is this? Exponent. So this becomes 2 times 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 2. So therefore this is 4 times 4 is 16 times 16. So what is 16 times 16? Let's see. 16 times 16, 36, 9, 16, that's 256. So 2 to the 8 becomes 256 bacteria in 8 hours. In 8 hours. Very simple, right? Okay, so that's pretty much the homework, guys. So for homework, you're going to find that on pages what? 29 and 30, numbers 1 through what? Numbers 1 through 63 odd. Okay? All right, so your homework. See you guys tomorrow.